Okay, so here's the key to practice exam number 3 coming at you. So yeah, you can find this key on our class notes document. So just click the link through D2L. But without further ado, 'cause there's been plenty of that already, let's solve some stuff. So questions number 1, which apparently was at one point in time worth 6 points. I think I meant to take that off. Oh well. The simple harmonic motion model of a spring is given by the equation d equals 8 cosine of 6 pi t, where d is in inches and t is in seconds. Find a few things. So first we want the maximum displacement. So to do that, we're going to be looking at the value of A. That maximum displacement is 8 inches. Since I just need the absolute value of A, because maximum displacement should be the same as the amplitude. Next, I want the time required for one oscillation, which means I need the period. So 2 pi divided by 6 pi is 1/3. So time required for one oscillation should be 1/3 of a second. Or 1/3 seconds, I guess. I think it's still plural, but yeah. And then I want the frequency. The frequency is going to be 1 over 1/3, which will simplify to 3. So that frequency is 3 hertz. Actually, let's be a little bit more direct about this. This will be 3 oscillations per second. And because it's oscillations per second, specifically per second, it is 3 hertz. If this were in minutes, though, minutes do not convert to hertz. Only 1 over seconds convert to hertz. But yeah. All right, numbers. Here, we'll leave a little bit more of that on the screen. I'll talk about the next one. Number 2, I keep wanting to call them number 6, but it's never number 6. Well, it will be in 5 problems. Anyway, I'm awake. A toy rocket is to be launched from the ground, aimed toward a big tree on the other side of a private fence. If it is 21 feet from the launching position of the base of the fence is 9 feet tall, what must be the minimum angle of elevation in whole degrees so that when the rocket is launched, it clears the fence? So here's where we should draw ourselves a fancy diagram. So I'll give myself a ground. Somewhere in the back, we've got a tree, right? That part is obviously super critical. You have to draw your tree. Your diagram won't be accurate. Oh, there's a fence hanging out here somewhere too, though. Let's change the fence back to that color. And what do we say? This out of a privacy fence. We should connect wherever our rocket is. Let's just say our rocket's over here. We'll use the rainbow star pattern for that rocket's flight path. And so then, what do we want to label here? We know that the fence is 9 feet tall, so I'll put a 9 right there. We know that we're 21 feet away from the base of the fence, so 21 goes right there. And we're interested in the angle of elevation, which is going to be that red angle right here. That ought to be enough to put it together, right? Yeah, I think so. So if we come to solve for that red angle, which I suppose I'm going to call theta, because I'm basic, theta should be the inverse tangent of 9 divided by 21. Nine divided by 21. There we go. We'll color code it. And we should get a number here, which means going to the internet for me, or a graphing calculator for you, or the internet if you want. You can use an internet calculator. I'm going to get the arctan of 9 over 21 in degrees. Oops. It would help if I spelled arc correctly. There we go. Okay, and so then 23.19 degrees. 2319. 2319. Yeah. So here's where something kind of unique to this problem shows up. Because we need to aim this rocket in order to clear the fence. And again, just because of the specific wording of this problem, the very specific wording of this problem that doesn't show up in a lot of other word problems, we have to take this step. But enough. Let's talk about it. Cool. So we must clear this fence. And so we're looking for the minimum angle of elevation in whole degrees. That means that the rocket will clear the fence. So even though 2319 would round down to 23, if I take an angle that's too small, my rocket is going to hit the fence. So a 23-degree angle will not get over this fence, even though it's what we should round to. So because of all of that, because we said specifically minimum whole degree angle that clears the fence, we have to round this one up, regardless of the decimal. And say it's 24 degrees. Again, that's just because of the rather specific wording of the question. Most of the time, if I say round to whole degrees, you would just round appropriately. Up if it's 0.5 or higher, down if it's smaller than 0.5. Yeah. Okay. Cool. So problem 3. So if you're watching the video later, I don't think that it's going to be recording the chat that's going on. So, quick question from the chat. Are we going to have one on the exam where we round up like that? Probably not. But who knows? Anything could change. I don't know what I'm doing. I'm glad I said that in the recording. I am so very tired. Okay, let's look at problem 3. We have the cotangent of the cosine inverse of negative 63 over 65. So let's talk about what's going on right here. The cosine inverse of a number, right? Anytime we're taking the cosine inverse of something, our result should be an angle. So we take some number negative 63 over 25, get its cosine inverse. The output there is an angle, which means I ought to be able to set up a reference triangle for this angle cosine, which is exactly what I'm going to try to do, except have it work out to a right triangle. There it is. Look at how well that technology works. And I'm going to put this triangle in quadrant 2. Since I'm taking the cosine inverse of a negative number, I know that cosine inverse is negative only in quadrant 2. So that's where my reference triangle goes. That angle alpha is going to be this one. It's going to be this one. There we are. And we'll slap some labels up there. Our adjacent side should be negative 63, while our hypotenuse will be positive 65. And we have a missing side that we're going to need to solve for. So if we use the Pythagorean theorem, we ought to be able to say that 63 squared plus an unknown y squared is equal to 65 squared, meaning that y squared is another number. It's 65 squared minus 63 squared. And that's 256. Which I believe means that y is plus or minus the square root of 16. Y equals plus or minus, wait, not the square root of 16, just plus or minus 16. Don't remember what I said there a moment ago. Right, cool. Y is either positive or negative 16. And we are in the second quadrant, which means that should come out to positive 16. Put our missing side over there. All right, so now we ought to have everything in order to be able to solve for the cotangent of alpha. So the cotangent of alpha, which is just the cotangent of this reference triangle, should be the adjacent side over the opposite side. So negative 63 divided by 16. So that's what goes in the box. Negative 63 over 16. All right, and then there's a multiple choice section on this practice exam. So keep in mind that, the actual exam is all multiple choice because it's on the internet. Because that's the world we live in. Do some rapid fire stuff. Get the exact value of each of the following. So first, we're going to be looking at the secant of, that must be pi over 3. Right, the tangent inverse of square root 3 is pi over 3. So then we want the secant value there, which is going to be 2. Cosine of pi over 3 is 1/2, and the reciprocal of 1/2 is 2. Then we want the exact value of the sine inverse of the tangent of 3 pi over 4. which means I need the sine inverse of -1, since the tangent of 3 pi over 4 is -1. So I want to find the angle where sine is equal to -1, but also is in the range of sine inverse, which is going to happen at -pi over 2. Not to be confused with 3 pi over 2, because that's not going to be the correct answer. So question 6 is trying to trip you up with the wording, trying to say the exact value or exact values. Tangent inverse of -√3 over 3 is /r. It's not going to be plural on r. It's always going to be is. If we're looking for the tangent inverse of some number, there's only going to be one solution. So don't let that stuff trip you up. The tangent inverse of -√3 over 3 is going to be -pi over 6. Right? We have to go to that -4th quadrant to get our answer. And √3 over 3 is one of the pi over 6 answers. So -pi over 6. Right, in 7, we've got the cosine inverse of the cosine of -pi over 3. And we want to come up with an answer here. So it's pi over 3. Let's talk about why, though. The cosine of -pi over 3 is going to come out to a positive number. Right, because I know that cosine is positive in the 4th quadrant. So if I take the cosine inverse of the cosine of an angle in the 4th quadrant, I want the reference angle that's in the 1st quadrant, because that's where cosine is positive. So that's like the just talking about it way, if you want to reason your way through it. But we could solve this one out just like we've solved all of the others out, and say this is the cosine inverse of √3 over 2. Since we know that the cosine of -pi over 3 is equal to the cosine of pi over 3, because cosine's even, that is square root of 3 over 2. Then take the cosine inverse of that and come back to pi over 3. I feel like I might have misspoken there somewhere, saying √3 over 2 when I meant to say pi over 3. So if you're watching this later, after it's been recorded, sorry about that. I might have misspoke. Good thing I'm going to make a new one of these every semester. Cool. Problem 8. Triangles ABC and PQR are similar. Find the length of side B. So, stuff we know then, if these things are similar, A and P are similar, B and Q are similar, C and R are similar, and B is going to have to be this side over here, because side B is going to be opposite angle B. Which means we should be able to set up a similar triangle equation. So they like this: B divided by the side it's similar to, which is 8.1, is equal to 2.7 divided by 3. Which means then that B is equal to 2.7 over 3 times 8.1, which is going to be 2.7 squared. So that'll be like 7.29. I suppose I should have written that in. Equals 7.29. Cool. Alright, hey look, even more multiple choice. Isn't that nice? Okay, so let's check this out. We have some words about simple harmonic motion. An object attached to a cold spring is from its rest moving down, distance of 9 millimeters, and it's got 1/6 oscillations per second. Figure out what the equation should be. So, some important things. That 9 millimeters means that the absolute value of A is 9. This 1/6 of an oscillation per second, that means that the period should be 1 divided by 1/6, which is 6. So B is equal to 2 pi over 6, which is pi over 3. Come highlight the fact that this thing says it's moving down first. Means that A is going to be negative 9. And then we've got A and B. All that's left to do is decide if this thing should be sine or cosine. And it's right here. Is from its rest moving down. Means that we're looking at a sine function. So put all of these things together to find our correct answer. Negative 9 sine of pi over 3t. Looks like it's option E right in the middle. Then problem 10. Runner begins at the starting line and proceeds in a direction that is 72 degrees west of north for 3.5 kilometers until she reaches a refueling point. Turns 90 degrees southward, running 6.5 kilometers to the finish line. Find the bearing from the starting line to the finish line. Draw yourselves a picture. Right. So let's slap something together. So initially, our runner is going to have a bearing angle of 72 degrees west of north, which means I'm going to start at the north line and then go 72 degrees to the west. If I do that with this ruler, I'll end up with an 18-degree angle. Since 90 degrees minus 72 comes out to 18. There we go. So we put some stuff together. We'll get ourselves a starting point. Guess I'm drawing this backwards from my starting point, but that'll be okay. She then turns 90 degrees southward. So take this angle, rotate 90 degrees southward, which, entertainingly enough, this is where our 72-degree angle is going to show up. At least, on my ruler. Then she runs a longer distance this way. And then let's also sketch the coordinate axes. I'll put a compass heading at my starting line. Try again. Compass heading at the starting line. And then I need to connect the last little bit right here. That looks good enough. All right, look at that beautifully drawn diagram, complete with all that stuff. So let's fill in the pieces that we know. We are told that we have an initial bearing angle of 72 degrees to the northwest. So this angle right here should be 72 degrees. We know how far we've been running. First, our runner ran 3.5 kilometers, then she ran 6.5 kilometers. So we'll label those two pieces. And then slap down a couple other things that we're interested in. Our bearing angle beta, that's what we're trying to solve for. We also have this green angle theta that's on the interior of the triangle. And we'll need to solve for that angle in order to get the bearing angle that we're interested in. So let's set that up. If I add the orange, green, and red angles together, maybe that's yellow, green, and red, whichever, I should get to 180 degrees since they make up one line all the way through. So 180 is equal to 72 plus theta, which is green, plus beta. Which means in order to get that angle beta, I'm going to need to get the angle on the inside of the triangle first. Fortunately, I should be able to solve for that. Theta is equal to the inverse tangent of the inverse tangent of 3.5 divided by, or no, 6.5 divided by 3.5. Should be opposite over adjacent. We'll end up with a number right there. I got 61.7. So 61.7 degrees. Plug that into the formula for beta, which would be 180 degrees minus 72 degrees minus 61.7 degrees. And we get a number there. I better take that to a calculator before I make a small mistake. So 180 minus 72 minus 61.7. And the number that I got was 46.3. And so with a diagram that's roughly to scale, that looks like about a 46-degree angle. So the thing we have to do in the end is put that bearing angle into an actual bearing. And if I'm at my starting line and going to my finish line, I have to go in a direction that's southwest. So my bearing angle should be south 46.3 degrees west. My bearing should be 46.3 degrees west of south. All right, I'm going to answer a couple of questions that were coming up in the chat recently. When does the exam open? It opens tomorrow, November 5th at 6 or 7 in the morning, and it stays open until this Sunday at 11 o'clock p.m. What date is Sunday? Sunday is the 8th. If you're watching this at not live, Sunday the 8th is when it closes. Then there's a question. There are a lot of questions about simple harmonic motion. Is that a big part of the exam? So on the exam, somewhere between 2 and 4 questions about simple harmonic motion. There will definitely be one question that's, here's a simple harmonic motion equation, answer a few questions. There will definitely be at least one question that, here's an object that's been pulled up from its rest position and released. What's its equation? Definitely at least one each of those 2 types of simple harmonic questions. And maybe more? Probably not more though, probably just those 2. Sort of depends on how I'm doing as far as points go. Because I am making an effort to keep every individual question worth 5 points or fewer on the exam. That way, you don't make a small mistake and it just totally wipes out your grade. So I try to have a high density of small problems, so that simple mistakes aren't as costly. Because I know those just happen. And then, can you go over determining the south or west of the bearing? Yeah, definitely. So when I'm coming up with a bearing, there are always going to be 2. Well, a bearing is made up of a couple pieces. It's made up of a heading, or a heading. It's made up of an angle and a compass heading. I'm using heading sort of loosely here. But the compass part is, just determining north, south, east, and west. So once we get the bearing angle, all that's left is determine which direction I need to be headed in. And that's as simple as just deciding which quadrant our line is in. So we're in quadrant 3, which is the southwest quadrant, so we're going that way, southwest. But maybe a better explanation of how to decide, if I'm sitting at my starting point, which is right here, this is my start, and I need to figure out how to get to my finish, which is over there. Just look at the direction I have to go to get from start to finish. Going from start to finish is southwest. Right, that's the southwest direction. And so that's how I knew what to get. Yeah, so if I were in quadrant 1, it would be northeast. So if I were asking for the reverse bearing here, if I wanted the bearing that went from finish to start, so say if I'm now at my end point, what direction would I have to look to find my starting line? That would be northeast. 46.3 degrees. Because the bearing angle is actually going to be the same from either point. The only thing that changes would be the cardinal directions in play. So start to finish is southwest, finish to start is northeast. Because if I redrew my compass lines, or my compass coordinate axes at the finish line, I'd find that my line, that rainbow line there, is in the first quadrant rather than the third quadrant. Oh yeah, we still have a bit more to go. So everything we've done so far is all the stuff that's on worksheets 9 and 10. And then these last few problems are off worksheet 8. So going back to graphs of secant, tangent, cosecant, cotangent. So which of the following correctly lists 3 asymptotes of y equals 53 tangent of 2x? So I'm going to take that 2x and set it equal to pi over 2 plus k pi. Because that's what I'm going to be interested in. So if I solve this thing for x, it's going to be pi over 4 plus k pi over 2. Or if I wanted to simplify that, pi plus 2k pi over 4. Which means that if I start picking some values for k, I should get pi over 4, and then 3 pi over 4, then 5 pi over 4, then probably 7 pi over 4, and that pattern is going to continue. Down here, this is for k equals 0, 1, 2, 3. So find the one that's going to list the correct looking stuff. It looks like it's C. So a question in the chat: how did I know which numbers to pick for K? So to be honest, I didn't know which numbers to pick. I just started with the easy numbers. I just started at 0 and kind of saw what happened. So if you got this question on the exam, probably it's going to be 0, 1, and 2, more than likely. But even if it's not, if you just start listing out from zeros, you might get 2 out of 3 of the asymptotes that show up here. So then you could, seeing that you got 2 of 3, then, just check the other one. Start working backwards, start at -1, -2, and see if you get the other missing egg, the other one that you didn't have out of that set. Because there are an infinite number of these asymptotes. So I don't always know where to start. I just have a good guess on where to start. Usually starting at 0 is the easiest place. All right, question 12. I just have to fill in some basic information about tangent, secant, and cosecant. So the big one, so I'm going to put it in red. The period of tangent is just pi, not 2 pi, unlike both secant and cosecant, which have a period of 2 pi. Then the range of tangent is all real numbers. while the range of the other two is all real numbers except everything between 1 and -1. Got just enough space to fit all that in. And then I want the general equation for asymptotes. X equals pi over 2 plus k pi. Same with secants. Pi over 2 plus k pi. But for cosecants, it's just x equals k pi. Nifty. And then I think in the last problem, we're going to have to actually put that into practice. Yeah. So given a cosecant function, find a bunch of stuff. Starting with the period, which will be 2 pi over 3, which simplifies to 6. Next, I want the phase shift. And the phase shift should be C over B, where here, don't forget, C is positive pi over 6, because C always has the opposite sign of whatever you can see in the function. So this is pi over 6 divided by pi over 3, which is going to come out to 1/2. Then we want that range in interval notation. Slide that over and make it smaller. That range in interval notation is -infinity to -10. Union 10 to infinity. So I'm going to be grabbing that 10 right there. Then I need the general formula for the asymptotes here. So I'm going to take everything that's on the inside of that cosecant function, which was pi x over 3 minus pi over 6, and set that equal to k pi. And then I'll spend do a little bit of work to solve that thing for x. So this means that pi over 3x equal to pi over 6 plus k pi. So that means that x then is 3 over pi times pi over 6 plus k pi, which simplifies to 1/2 plus k. Nope, let's try that again. 1/2 plus 3k. There we go. 1/2 plus 3k. Yeah, I thought that was going to be the end.